What you're observing right now is called a Venus solar transit. This is a very rare event that doesn't happen very often, but actually occurred in 2012 and also in 2004 before that. But the one before that was in 1882. That's over 100 years ago, and the next one will also occur 100 years from now. This event is really rare, and when it occurred in 1761, a Russian scientist and polymath by the name of Mikhail Lomonosov. And when Venus passed in front of the Sun, Lomonosov witnessed something around it. He saw a little ring around the planet, which he hypothesized must have been due to atmosphere. And today we know he was correct, and we know that Venus not only has an atmosphere, but has one of the thickest atmospheres in our solar system. So thick, in fact, that if you were to stand on the surface of this planet, you would experience just as much pressure as you would on the bottom of 1,000-meter ocean. In other words, the pressure is equivalent to the bottom of a relatively deep sea. And today we're going to be talking about this beautiful but scary planet called Venus. We're going to talk about its mysteries, its facts, its awesome atmosphere, and also about a potential colonization mission one day that we might even complete in our lifetime. Welcome to What the Math. And welcome to Venus. So this is Space Engine using the miscellaneous textures specifically for Venus. However, you know what? I don't really know why these textures are even here, because the thick atmosphere of Venus prevents you from seeing anything on the surface. I actually have to go way down to the surface to see anything. Now, Venus's atmosphere is actually really interesting. It's composed of mainly carbon dioxide, so this is really extreme case of greenhouse effect, but at the same time it also contains a lot of other things like sulfuric acid. It contains hydrogen sulfides, and a lot of that stuff is in the atmosphere and also forms the clouds. Because of these sulfuric clouds and because of these hydrosulfuric basically acidic clouds, Venus also has a very high reflectivity, high albedo effect, which actually prevents most of the sunlight from reaching the surface. If you were to stand on the surface and if you were to look up, you wouldn't really see much. It would be really dark. You wouldn't see beyond maybe 3 kilometers or so in a distance, and you would essentially always be in this kind of a perpetual darkness. It's really kind of hard to see anything. But it also contains other things. It contains oxygen, it contains nitrogen, it also contains just normal hydrogen. And because these gases are a little bit lighter than carbon dioxide or sulfuric acid and so on, a lot of them end up here on the surface. So if you were to go into the upper atmosphere, you would actually find an atmospheric pressure and atmospheric conditions not very different from our planet Earth. Now, we'll talk about this near the end of the video, but right now let's just talk about the cool facts about Venus. So right now I'm in the upper atmosphere, but as I descend around this part, this is where the really dense part of the atmosphere begins. You can actually see the atmospheric pressure right here and temperature right here. This is current temperature, this is atmospheric pressure. And as I descend, you'll see how it dramatically starts increasing. So at an altitude of about 50 kilometers, we have an atmospheric pressure of basically what it is on Earth, 1 atmospheric pressure, and the temperature here is anywhere between minus 28 degrees and possibly 0 degrees, and you can kind of see the surface as well. So if I were to actually accelerate this, you would actually see the surface. Here we go, nighttime, and daytime is coming, I hope. Oh, that reminds me, Venus actually has really interesting daytime, nighttime. One day here lasts for a very long time, specifically something like 85 days of darkness and daylight, which is why I had to accelerate time so much, because one day here is really long. But nevertheless, even the night side of Venus is extremely hot, and I'll explain to you in a second why. So let's actually descend a little bit lower. So as you see, as I come closer to the surface and as we go beyond 1 atmosphere, the temperature starts increasing dramatically. So at the point of about 30 kilometers, the temperature is already near the boiling point of water. Here, as you fold closer to the surface, it's just skyrockets. Atmospheric pressure increases really fast, temperature increases really fast, and here right on the bottom, and it's not really simulated well in this game, but what you would find on the bottom is really crazy. You would find something called supercritical carbon dioxide. Now, what is supercritical carbon dioxide? It's essentially carbon dioxide, which, you know, stuff that you're breathing out right now, or that I'm breathing out as I'm talking, but it's not air or it's not gas anymore. It's actually turned into this kind of a liquidy state where it behaves like a liquid. So in other words, there's literally an ocean. This planet is kind of covered in this ocean of super hard, super pressurized carbon dioxide that is just everywhere. It's literally covering this planet. And interestingly, this is the reason why on the night side, if you go to the night side of this planet, the temperature is pretty much the same as on the bright side, because this ocean of carbon dioxide is really good at transmitting heat, and it actually helps the planet to maintain a very similar temperature across the entire surface. So in a sense, it's sort of like a heat sink. It absorbs heat and it transfers it everywhere across the planet. Now, why is this planet so hot? And you may have actually heard this before, and this, of course, because of the ridiculous amounts of carbon dioxide, which is a greenhouse gas. So Venus is an extreme case of what would happen if our planet suddenly had huge amounts of carbon dioxide. And this is why the surface temperature here is something like 440 up to 500 degrees Celsius. It's super hot. Whenever we landed any probes on this planet, they essentially just melted from the inside, because most of the materials we make space probes from are not able to survive such high temperatures and also such high pressures. And just so it happens, look at that, we can actually see Earth from Venus right now. There's Earth right there. It's very close to the sun. So this is what Earth would look like if you were to orbit in the upper atmosphere of Venus and to look up in the sky. And by the way, this planet is actually even hotter than Mercury. Mercury, that's even closer to the sun, is not as hot as Venus. So the greenhouse effect on Venus is very, very powerful. If you were to remove all of the clouds from here, which we'll do in Universum Mux 2 in a few seconds, if you were to remove all of the clouds, it would actually cool down dramatically. And the thing is, if you actually look at Venus from a distance, it doesn't really look like anything special. So this is what it looks like. I'm going to accelerate time just to show you how the clouds here move. And interestingly, the clouds even move faster than the spin of the planet. And that's because the actual winds are formed not by the rotation of the planet, but by the high temperature differences. So the convection here is what drives these really relatively fast winds in the upper atmosphere. So it's really interesting because the winds really move faster than the rotation. Now, the most recent mission to Venus was called Venus Express, and it was actually able to investigate a lot of the atmospheric details about this planet, and also found a lot of really cool things, including magnetosphere, which I'll explain a little bit later. But what we're curious about, and what we're interested in, is the fact that here, right in this part of about 45 to 50 kilometers, this is where we could actually have an actual colonization mission, because the atmospheric pressure and the temperature here are very similar to Earth. And so if we were to actually put some kind of a Zeppelin or a balloon or some kind of a flying colony right around here, at a height of anywhere between 38 to maybe 40 kilometers, we might actually be able to even live here. This is actually livable conditions, and other than, you know, the fact that you have a chance of falling down and dying in this hellish pit of Venus, this would be actually a pretty interesting colonization mission. So as much as we talk about Mars, it's really Venus that's very similar to Earth, and it's really Venus that has a potential for having actual life, because here, right in this point on Venus, this is where you have really, really Earth-like conditions, at least for our solar system. In other words, what you'll find here is oxygen, you'll find nitrogen, you'll find just enough carbon dioxide for plants to survive, and there's enough solar radiation and sunlight that you can kind of survive and not really die. And it's warm and it has pressure, so at this altitude, it's possible that we might have at least microbial life, in a similar sense that we have that life on Earth in our clouds. So our clouds actually do have some microbes in them that also live in a sort of a similar condition to this. Anyway, so I'm going to actually go into Universum Mux 2, and we're going to try to terraform this planet, because I think for Space Engine, as much as I would like to explore this planet in more detail like I did with Mars, we just can't really see any surface features, and all you're looking at is basically a very, very large cloud. So unfortunately, it's not a particularly exciting planet to explore. And so this is what Venus looks like in Universe Sandbox 2, and you can actually kind of see the surface, even though this is probably not very realistic, but at least we can now actually explore the surface just a little bit. So if I were to remove the atmosphere and the clouds, you can kind of see what we've mapped so far of Venus, and this is all using radar-based satellites that basically map the surface. But like I said before, the actual surface is covered with this liquid carbon dioxide that essentially is like an ocean covering the entire planet. Alright, so let's remove all of the atmosphere from Venus and see what happens in terms of temperature. So we're going to observe the temperature and we're going to see how this changes if the entire atmosphere is actually removed completely. So we now have zero atmosphere. Welcome to Venus with no atmosphere. And let's just wait and see what happens here and how much of this is actually from a greenhouse effect and how much of this is from just being heated up by the sun. Okay, so we're gonna wait for this temperature to decrease a little bit. I actually probably should enable the graph again. And while we're waiting, let's talk a little bit about some of the cool things about Venus, and specifically how it maintains its atmosphere. So when I was younger, when I learned about how Mars lost its atmosphere, and specifically from the solar winds and solar eruptions, I realized that, okay, so that makes sense, you know, Mars lost its atmosphere because the solar winds blew the atmosphere away from it. Earth is protected from that by magnetic fields. Now, what's up with Venus? How does it protect itself? Because if you were to enable magnetosphere, you would see that there's nothing here. What protects its atmosphere from the sun's crazy amounts of solar flares and solar winds? There's got to be a process that protects its atmosphere, and there's got to be some way for it to maintain such a thick atmosphere. And of course, more recently, specifically in 2011, we've discovered this process, or at least we think we did. So here, there is actually a magnetosphere formed by the upper atmosphere of Venus called ionosphere. Well, our planet also has ionosphere. It's where a lot of the particles of air turn ionic, they turn magnetic because of the effect they get from solar radiation. So in other words, when the solar rays hit the upper atmosphere, they turn some air, some of them particles, a little bit magnetic. They turn them a little bit electrical, and they're called ions. And so these ions actually create, and you can see the picture of this here, create this kind of a magnetosphere behind, a little bit around, but also behind the planet. And it's very similar to a tail of a comet. It's actually kind of interesting to see because it does look like a magnetic comet tail. But all of this is formed by the sun. In other words, the only reason there is a magnetosphere is because the sun radiation, sun rays, are hitting the atmosphere of Venus, and they're making Venus magnetic. And one of the reasons why Venus may not actually have the inner magnetic field like our planet does is because it's spinning so slow. Look at how slow it's spinning. Its day is ridiculously slow, and so it might not create enough spinning effect inside of it for it to actually create its own magnetic field. And even though the sun's ultraviolet radiation does create this magnetosphere around Venus, a lot of the other atoms, like for example oxygen, hydrogen, and helium, are actually still lost from the surface, because in a similar way that Mars lost its atmosphere, some of the particles are still kind of escaping the atmosphere. So Venus is losing a lot of its own atmosphere, specifically things like water. So if there's water on the surface of Venus, it becomes hydrogen and oxygen, and those molecules then escape because of the solar flares hitting them when they're in upper atmosphere. And most of oxygen and most of hydrogen would actually be in the upper atmosphere because it's a lot lighter than carbon dioxide, so that it would actually float on top of Venus. And so if you were to go behind Venus on the dark side, if you were to go right here, this is where you would find a lot of the oxygen, a lot of the hydrogen escaping into the outer system, and possibly even landing back on Earth. And surprisingly, it's taking a little bit too long for this planet to cool down, so I'm going to accelerate time a little bit just so we can actually get to that livable atmospheric temperature and surface temperature. And while we're waiting again, let's talk about the mission that is currently coming to Venus. Actually, it's a mission that was launched in 2010, but Unfortunately, what happened to that mission is that it failed to enter Venus' atmosphere. There was a mistake and a problem that caused this probe to overshot, and it had to wait 5 years to come back to Venus. And the probe I'm talking about is actually from Japan. In Japanese, it's known as Akatsuki, which stands for Dawn, so it's a Dawn mission. And it's a mission to basically explore a little bit of Venus' atmosphere, a little bit of its regions, and to basically take more photos and to kind of try to get a little bit more knowledge about what's happening with greenhouse effect on Venus. Alright, so here we go. After about 40 years, the Venus surface has finally cooled down a little bit. You can actually see how it cooled down on this graph. It went from about 500 degrees Celsius to we're now at 30 degrees Celsius. And this is when we can start or try to start terraforming it a little bit. And so what I actually wanted to start with is that our planet Earth was kind of similar in terms of temperature and pressure when it was just born as well. So in other words, when our planet was just created, it actually had a ridiculously high pressure, ridiculously high temperature, and then something happened and it lost all of that and became what it is today. Now, Venus may have been like our planet as well at some point and then returned back to this state. So in other words, it seems like a lot of planets have something happen to them that causes them to come back to the state of high pressure and high temperature, and they also lose a lot of other things like oxygen and water. But in case of Venus, it used to be very Earth-like. There's a lot of signs that it may have had liquid water before, and that it may have been livable and possibly even had, for all we know at least, it may have had life. So what exactly caused Venus to become so ridiculously hot and so ridiculously highly pressurized? It's very likely that when plate tectonics stopped on Venus, and plate tectonics refers to the continents moving around, usually due to ocean pressure or water pressure on the surface. And so because of plate tectonics, once they stopped, the carbon dioxide stopped being recycled, because carbon dioxide recycling depends on plate tectonics, and it started to accumulate on the surface to the point where it is right now. And because of the accumulation of carbon dioxide on the surface of Venus, the greenhouse effect became so strong that now the planet is essentially unlivable. And this possibly may even happen to our planet. If our oceans disappear and plate tectonics stop, we're going to return back to the state of high pressure and high temperature as well. And this may even happen relatively soon, because plate tectonics do not last forever. And I think we are successful at terraforming Venus. So we currently have a surface temperature of about 15.2 degrees, very similar to Earth. The albedo here is really high, so in other words, this planet is really reflective, and that's because it actually had a high albedo. If I were to decrease it to more realistic values, it's actually going to go, it's going to get really, really hot. It's actually possibly going to get to about 80 degrees Celsius. Surface pressure is a little bit lower than on Earth, so it's similar to altitude of about 2 kilometers, 3 kilometers on the mountain. But it's not something people have trouble with. Usually surface pressure of about 81 kilopascal, or about 0.8 of actual atmospheric pressure, is not really dangerous for us. We can usually survive this pretty easily. So the only thing we're lacking on Venus right now is, of course, water. So we need to make some water. We're gonna add it, or actually create it from the surface by just redistributing some of the mass here. And you can see as soon as I added water, we have clouds now, and this will give us liquid water on the surface as well. And even though we can't really see the water on the surface right now, if I were to disable the atmosphere, here you go. This is what the Venus surface looks like. We have a lot of water here. And really, the only thing we're missing is, of course, a magnetosphere. Now, because our atmospheric pressure is so much lower now, there's a very high chance that the sun is going to start bombarding this planet with its solar radiation, solar flares, and Venus might actually start losing a lot of atmosphere because of that. And I believe this game simulates this quite well. If I were to actually look at the materials right here, it says we're losing 120 kilograms per second. That is a lot of air that's being lost. But I think this is actually enough for us to survive on this planet for a few hundreds of years. After that, maybe we can find a process by which we can regenerate the atmosphere. But for the time being, I think we're fine. Even though we're losing so much, we can maybe figure out how to either make magnetosphere artificially or just add more air as it disappears. And before we finish this video, let's just talk a little bit about the possibility or the actual possibility of sending a colonization mission to this planet. So if we were to send a flying balloon mission to the upper atmosphere, it would actually be able to even float by itself without anything because it would have oxygen inside. So imagine a helium balloon flying on our planet. It would be the same thing because Venus has mostly carbon dioxide in the atmosphere and oxygen is lighter than carbon dioxide, so it would actually float on top. And if it can float at a distance of about 40 kilometers, we would even have livable conditions. We can basically open windows and it's going to be relatively windy, but also warm, and the pressure would be just fine. So we can actually replenish our oxygen, and we don't even have to build anything except for maybe a water generator. And this is also the region where we think maybe there is life because it has a very Earth-like conditions, except for, of course, for maybe lack of water. We don't really know how much water there is in the upper atmosphere of Venus. But the other cool thing is that because Venus is so reflective, a lot of sunlight is reflected back from the surface, and so you could actually make a kind of a probe or a kind of a colony that has solar panels on the upper side but also on the bottom, so you can actually get energy by collecting the light from the bottom that's being reflected from the surface of Venus, which is, I think, is pretty cool. In other words, you can double your solar energy production by essentially having Venus atmosphere reflect most of the sunlight. And because Venus is much closer than Mars, I'm actually really surprised that more space agencies do not consider launching a mission here first, because I think it would be a lot more cooler if we actually have this flying balloon colony, and it would be a lot cooler if we actually try to colonize upper atmosphere of Venus rather than colonizing Mars. I mean, Mars is interesting and all, but it's empty, it's dry, it's farther away, it has a lot less mass than Venus. And if I were to put Mars in comparison, you'd see what I mean. So this is Mars in comparison to Venus. I can actually make them orbit probably. Since Venus has no natural satellites, the Mars is going to be... oh boy. I didn't expect that to happen. I think I accidentally smacked Mars into Venus. That's why it's super hot now. Anyway, I'm gonna do this slower. There we go. So we're gonna make an artificial satellite of Venus, and we're gonna return Venus back to its original state. And its mass is similar to Earth, so the gravity here would be relatively comparable. And everything else is. I mean, this is really as Earth-like as it gets, except for, of course, for the ridiculously high pressures and temperatures that we can avoid by living in the upper atmosphere. And I think this is all I wanted to say about this awesome, beautiful planet. Now, this is our closest neighbor, so I definitely think we need to focus on Venus and not on Mars. And before we finish this video, let's actually go into powers, and we're going to stop velocities, and we're going to have Mars meet Venus face to face. So hold all velocities and maybe slow down time a little bit, and let's watch them collide in the beautiful harmony of Mars meeting Venus. Awesome, look at that beauty. Alright, so this is the end of this video. Hopefully you guys enjoyed watching this, and hopefully you learn a little bit more about Venus and why it's absolutely awesome and why we should go back soon. There's quite a lot of missions that are planned. I'm going to talk about those missions in future videos. And don't forget to subscribe, don't forget to like this video, and if you did enjoy Universe Sandbox 2 videos that I've been making, check out the ones that you may have missed right here. Alright, thank you guys so much for watching. I love you so much. You're amazing, and game you later. And bye-bye.